Hello, my name is Anastasia, and today I will present a topic of how analog and digital multimeter testers work. This is my laboratory assignment for the electric circuit analysis class led by Professor Rosemary Cretu. We will proceed with this. So overview. Today we will talk about an introduction to what multimeters are. Then we will proceed with some background information and history. Our next slides will talk more in detail on the mechanism for analog multimeter and digital multimeter. So let's start with the introduction. Introduction to multimeter. A multimeter or multi-tester, also known as a VOM, volt ohm millimeter, is an electronic measure instrument that combines several measurement functions in one unit. A typical multimeter can measure voltage, current, and resistance. Analog multimeter use a microammeter with a moving pointer to display readings. Digital multimeters, also referred to as DMM or DVOM, have a numeric display and might also show a graphical bar representing the measured value. Digital multimeters are now far more common due to their cost and precision, but analog multimeters are still preferable in some cases, for example, when monitoring a rapidly varying value. So let's start with the background. Evolution of a multimeter. The first moving pointer current detecting device was a galvanometer in 1820. They were used to measure resistance and voltage by using a Wheatstone bridge and comparing the unknown quantity to reference voltage or resistance. While useful in the lab, the devices were very slow and impractical in the field. These galvanometers were bulky and delicate. Multimeters were invented in the early 1920s as radio receivers and other vacuum tube electronic devices became more common in the households. The invention of the first multimeter is attributed to British post office engineer Donald McAdee, who became dissatisfied with the need to carry many separate instruments required for maintenance of telecommunication circuits. McAdee invented an instrument which could measure amperes or amps, volts and ohms, so the multifunctional ammeter was then named avometer. Amps, volts, ohms. The meter comprised as a moving coil meter, voltage and precision resistors and switches and sockets to select the range. Donald McAdee continued to work for the post office until his retirement in 1933, even though he made his own company. His son, Hugh, joined the company in 1927 and became technical director. The first AVO was put on sale in 1923, and many of its features remained almost unaltered through to the last Model 8, that is displayed on the screen. So, analog multimeters. A multimeter may be implemented with galvanometer movement, or less often with a bar graph or simulated pointer, such as an LSD or vacuum fluorescent display. Analog multimeters are common. A quality analog instrument will cost about the same as a digital multimeter, or DMM. Analog multimeters have the precision and reading accuracy limitation, and so are not built to provide the same accuracy as digital instruments. Analog meters are also useful where the trend of a measurement is more important than the exact value obtained by a particular moment. A change in angle or in proportion is easier to interpret than change in a digital readout. For this reason, digital multimeters often approximate this with a bar graph. The most effective of these are arranged in an arc to simulate the pointer of an analog meter. Analog meter movements are inherently more fragile physically and electrically than digital meters. Many analog multimeters feature a range switch position marked off to protect the meter movement during transportation, which placing low resistance across the meter movement, resulting in dynamic braking. Meter movements as separate components may be protected by the same manner by connecting or shortening a jumper wire between the terminals when not in use. Meters which feature a shunt across the winding, such as an ammeter, may not require further resistance to arrest and control movements of the meter needle because of low resistance in the shunt. The meter movement in the moving pointer analog multimeter is practically always a moving coil galvanometer of the DR Snowball type, using either jeweled pivots or taut bands to support the moving coil. Because of the absence of amplification, ordinary analog multimeters are typically less susceptible to radio frequency interference, and so continue to have a prominent place in the field, even in the world of more accurate and flexible electronic multimeters like digital multimeters. So how does an analog multimeter work? An analog multimeter is a meter that can measure two or more electrical properties and display the measured properties along a calibrated scale using a pointer. An analog multimeter uses an electronic component called a DR Snowball movement to move the pointer along the scales. To display measured values from the test leads are connected to circuit, device, or circuit components. Most analog multimeters have several calibrated scales for a single meter movement. On the GM instruments VOM shown, the calibrated scale corresponds to the different function range switch settings that include off, ACV, volts, batteries check, ohms, DCA amps, and DCV volts. The meter's number is stored with the function range switch set to the off position, as for the reasons stated before. Okay, now we will move on to digital multimeters. Modern multimeters are often digital due to their accuracy, durability, and extra features. In a digital multimeter, the signal under test is converted to a voltage and an amplifier with electronically controlled gain per conditions. A digital multimeter displays the quantity measured as a number, which eliminates parallax errors like analog multimeters do. Modern digital multimeters have an embedded computer, which provides a wealth of convenient features. Measurement enhancements available include auto ranging, which selects the correct range for the quality under test. Auto polarity for the direct current reading shows the applied voltage is positive or negative. Sample and hold, current limited test for voltage drop across semiconductor junctions, a graphic representation of the quantity under test as a bar graph, a low bandwidth oscilloscope, and many more types of meters. Modern meters may be interfaced with a personal computer, USB connection, and instruments such as IEEE 488. The interface allows the computer to record measurements as they are made. Some DMMs can store measurements and upload them to the computer to make it easier. The first digital multimeter was manufactured in 1955 by Nonlinear Systems. It is claimed that the first handheld digital multimeter was developed by Frank Bishop of Intron Electronics in 1977, which at the time presented a major breakthrough for servicing and fault finding in the field. The operation of digital multimeters is very straightforward. Using today's IC technology, they are easy to develop, build, and use. Although they are very different to that much older analog meters, their basic functions is essentially the same. Although using digital technology, they are able to incorporate many more measurements. Like any test instruments, the way the digital multimeter works has an impact on the best way to use it, and understanding the operation can help make the most of it and understand why some measurements may not work out the way they were expected. When looking at how DMM works, one of the key processes that occurs within its measurement takes place of voltage measurement. In fact, any other measurements are derived from the basic measurement using Ohm's law. One of the key processes involved in this is that of how analog to digital conversion. There are many forms of analog to digital converter, ADC. However, one of the most widely used in digital multimeters is known as the Successive Approximation Register, or SAR. Some SAR may only have resolution levels of 12 bits, but those using test equipment using DMMs generally have 16 bits or possibly more depending upon the application of the DMM. I actually have a sample of a digital multimeter. This is Fluke. As you can see, it's very simple. You just switch on what you need to measure, plug it in, and here are the two needles. So let's now compare analog multimeter to digital multimeter. So one of the first things that come to mind is accuracy. Analog multimeter have a typical accuracy of 5%, but care has to be taken when reading to avoid parallax errors. As the meter ages, the magnetism in the coil degrades, which also affects the accuracy. A digital multimeter accuracy is 3%, but very easy to read and no adjustments are necessary. These figures are typical but vary between manufacturer and model. A modern top-range DMM can have an accuracy of as high as 0.5%. The next comparison will be input impedance. The input impedance of an analog multimeter is measured in ohms per volt. This varies for different ranges and can have a shifting effect on the circuit being measured. A DMM input impedance is much higher and constant across the voltage ranges. For current measurements, both analog and digital multimeters use shunt resistors. This needs to be as low as possible so as not to affect the current measurement. Next one is calibration. An analog meter has a screw adjustment that needs to be turned to make the pointer start at 0. That has to be done in accordance with the user manual of the meter, has to be knocked or subjected to shock. Varying signals. If you have a voltage, a current, or resistance that continually changes, then a DMM will vary its reading on display. Although the ADC on the digital multimeter is capable of very fast readings, your eyes could not read the display at the speed, so the readings are slowed to a few readings per second. However, an analog meter is much faster and easily capable of reading signals at 50 times per second. Due to inertia of the meter needle, the readings will not be of great accuracy though. If signals change faster than this, then the oscilloscope is required. Let's conclude what we talked about. Today we talked about multimeters that are tools to measure the current, voltage, and resistance. They are very useful instruments that can be utilized in a number of fields, their primary users being electricians. There are two primary types of multimeters, one being the analog and the other being digital. The primary difference between two is a display. An analog multimeter uses a needle to show the value, while a digital multimeter will show the results as numbers on the screen. There are pros and cons to both devices that we talked about previously. And then the applications of them both are very different, and they're used in every field of electronics, telecommunications, electricians in the world. And here is my website. Thank you very much.